Peerlyst Tel Aviv Meetup. We try to do a monthly security meetup, either here or somewhere in Tel Aviv. There's another one on Monday night on authorization list authorization at the Saludo office on Rothschild. So if you take a look at the meetup group, you can find the address for that. Tonight, Or has been kind enough to come in to talk to us about why MFA, or multi-factor authentication, is useless.
Thank you. There's no need for a mic, right? You can all hear. Awesome.
Okay. Does he need the mic, or can you hear okay?
Can you hear okay? So let's try that. Okay, so welcome everyone. You'll have to excuse my English for the next 5 minutes. It's going to take me some time to warm up, so that's what it's like when you live here. I called this presentation "Why MFA is Useless." That's the purest appropriate name for it. It's actually based on a different presentation I've presented in a conference called the SECONF. It's the Selenium User Conference. Selenium is a browser automation tool where developers can use it to programmatically control the browser to do all sorts of stuff. So it can open pages, you can browse through a whole website, make clicks in the web page, and then make all sorts of assertions about what happened, if a certain element was in there, etc. So the presentation I originally given was called. I'll restart the presentation. Sorry. Technical issues. It's always the most fun. And we should be good to go. So it's not that multi-factor authentication is really useless. It's not the perfect solution. And we're going to talk about what's multi-factor authentication right away, and why is it useful, why it's not useful, and we'll get there. So as I said, the original presentation was called Automating Multi-Factor Authentication. The focus was on automation of multi-MFA processes. And before we start, I'll just give a brief introduction. My name is Or. I used to work with Eric in Greenfield as a mobile developer. Right before that, I worked for the Ministry of Defense as a security researcher, and today I'm working as a research engineer in a company called Forter. We provide e-commerce fraud prevention solution. So basically, we see all the transactions that user made in your website, and then we are able to tell you whether a specific transaction is not legitimate, if it's a fraudster trying to buy things in your website with credit card that he does not own, he or she. And as a research engineer at Forder, my day-to-day work is to find new methods to catch these fraudsters and find indications that these are people trying to hide their identity, etc., etc. One of the things that Forter does is basically it comes to the customer, the website operator, and it tells them, you don't need multi-factor on your website. You don't need to do phone verification using SMS. You don't need to ask users to take more steps when they try to sign into their account. It's not necessary. We can tell you whether all the actions in the website are legitimate or not. So this is not the key product. The key product, as I said, is simply decisions about whether to approve or decline specific orders in your website. In e-commerce, the orders, credit card payments in e-commerce are not insured. It's something that continued from the way it worked before. You had phone orders and internet orders. ones only use credit card inside the store. So you'll swipe the card and you'll have to sign on the note that you're getting. And if you sign that note, the seller had to make sure that your signature matches the signature on the note, on the back of the card. And the credit card companies told them, if you do that, if you make sure the signatures match, then we'll cover your losses in the case the card was stolen or this transaction was not legitimate. When the internet got into the picture, it started actually with phone orders and Macy's. Macy's would mail you a catalog with a bunch of products, and you could just phone them, give them the credit card number over the phone, and they'll ship the product to you. So credit card companies came and said, you don't have any way to make sure that the signature match because you can't see the card, so nothing is insured. So the way it works today, if I were to sell laptops and someone would buy a laptop from me with a stolen credit card, you could buy it with the next day shipping, you'll have the product the next day, and at the end of the month, me as a business owner, I'll receive a note from the bank saying, listen, this specific transaction is fraudulent and you're not getting the money for it because you didn't verify that it's the actual card owner. So I'm staying without the computer and without the money. Okay. What's gonna happen today is, this is not interesting, I think, to this audience. It's the way Forger developed features, and this is also not relevant because we have time for questions today. Yeah, we're gonna talk about what's MFA, first of all, and then we're gonna talk about all sorts of ways to bypass that automatically, which is basically why it's not useful. And I think this presentation is going to give you the background about all the common practices today people use, and also where the market is going. Yeah, this is it's not going to make you any kind of expert, but I hope. It's very important to put disclaimers on the presentation when you present to an audience because they come with certain expectation, and then it's called automating MFA. Why didn't you explain how the algorithms work, etc., etc. So it's intended to give you the background and everything necessary to really understand the subject and do stuff your own. So what's MFA? Multi-factor authentication, and I'm calling it MFA because it's really annoying to say the whole 3 words. It's a way, basically, to authenticate the user, to make sure that the person you're talking to or communicating with is the person you're thinking. And it's done in a few ways. You have the multi-factor authentication, which basically means you're gonna have to ask from the user. Let's take a sample case where the user is trying to log into a website, into his account, his email account. So you as a email service, what you're doing is you're asking the user to provide you his password, and that could be it, but this is a single factor, just the password. It's something the user knows. And when we're talking about multi-factor, we're talking about asking the user for other properties that he has, such as changing token. For example, you have apps like Google Authenticator, and people used to have physical token. You had this little thing on your keychain, which had 6-digit code that we're changing. Yeah, Eric is holding one. So this is how one.
This is a virtual token.
This is a virtual token, but this is another form of authentication. So I could ask my user to provide me that changing token as a single factor as well. The reason we're using multiple factors is because when an attacker tries to gain access to your account, he has to also have all the factors that are used to gain the access. So let's say I have the password. This is something I know. I remember the password. And I have an app on my phone with a changing factor, which is something I can't remember because it's changing every 30 seconds. It's basically a 6-digit code, which is derived from a very long secret key I have.
It's something you have.
Yeah, so this is the other factor. I have the password, which I know, and I have the token, which is something I have. And I have because it used to be an actual token, actual physical keychain thing. And when people are talking about MFA, about multiple factor, they're usually talking about two-factor authentication. Talking about password and something that is changing every time. So the token, or I don't know, receiving a push notification to your phone and then pressing it's me signing in. But these are still two separate factors because the phone is a physical device.
It's something you have.
Yeah, it's something I have. So if an attacker was trying to gain access to my email account and he knows my password because, I don't know, he pitched it away from me in a website, he tricked me into giving it to him, then he'll still have to gain access to my phone in order to do that. And that's the point of it. And it's helpful because I have the assumption, and I guess many other people have the assumption, that you want to protect your users, you want to protect your system. You want to make sure that only the people that are supposed to have the access actually gain it. And using multi-factor authentication basically places and creates more barriers to a hacker in order to gain access to their account. So let's say that all you have to do in order to log into a machine I have is to have the password, the word password. That's great, but once someone achieved it, he can just reuse it. And when every login into that machine has to first use the password, then also provide something that is changing all the time, and it's not available on my computer, then even if someone hacked me, that's not going to help. A good or bad example for that is it's some kind of two-factor authentication, but when you're going to an ATM and you're trying to withdraw cash, you have to provide your physical card, the magnetic card, and put it inside. This is something you have. And you also have to put the PIN code, which is a password you remember. So this is some kind of two-factor authentication that you do in order to actually get money outside. So now we're going to take the pace. We're going to do it a bit faster. We have a few common practices that you can see available online today. You can see it in websites, you can see it in phone systems, etc. The first thing is 4-digit code or 6-digit code. That's not another factor. Let's put it right away. It's having me typing in a password and then typing in another 4 digits, which are like my secret PIN code. That's not helpful because it's the same thing. It's never changing. And it's basically like splitting my very long password into 2 parts. It's something I know, okay? And if someone gained access to it once, he can always reuse it in order to log into my account. So that's not helpful. And the slides are going to be available right after the presentation. So if you want to take a look at it, then I've added a table for each type of the multi-factor method. That basically puts everything on it. So when I'm saying, using 4-digit PIN can be brute forced, there's a disclaimer to it because it really depends on the way you develop your system. So if you're limiting the user to providing 5 different PIN codes in a certain time frame, then it's a bit more complicated to brute force the password, but it's possible. And again, this is not another factor because it's a password. You remember it, you know it. And this is, I think, today's focus about both useful and not useful way of authentication, SMS verification or automated phone calls. So this is an actual second factor because we're talking about your phone. Your phone is a physical different factor. If you left home without the phone, you probably won't be able to access your account because all the whenever you log into Twitter or Facebook, if Facebook believes that this is not you, they might show you an alert saying, hey, it looks suspicious, so we sent you a 6-digit code to your phone, please type it in and then we'll know it's you and it's okay to let you into that account. So this is a physical different factor. It's something you have. So as we said, there's something you know, something you have. And thank you that for asking the right question at the right time. I did use these metaphors originally presenting it. So this is actually having a physical multi-factor in addition to just knowing your password. There are good things to it. An attacker, if someone hacked your computer, that's one thing. But if in order to gain access to your important information, he has to also hack your phone, that's a whole different story. And we're talking about security and stuff. So hacking computers is a completely different thing than hacking phone devices.
Although Apple has made it much easier.
Yeah, yes and no.
If you connect your phone to your computer, your iPhone to your Mac, which most people that have both devices do, then you can inject stuff from your Apple to your Mac, or even once the iPhone gets an SMS, the Mac can read it.
Yeah,
so
but
if
you have to physically enable it at least once. And again, this is a feature, but in this case, when you're actually receiving the codes to your computer, the SMS messages to your computer, this is not a different factor. It's physically the same device. So you're correct, beside one thing that this is not the case we're talking about. I also have my, we use Okta for MFA in the company I'm working for, and I have the one-time password token in 1Password on my phone. And my 1Password is synced into my computer. So yeah. So what I did is separating, creating a standalone vault in the phone. So this is not happening anymore. The thing about phone, as Oded said, first it can be synced to your computer, and then it's losing the purpose. Right? And another thing is that phone numbers can be hijacked. You have people manipulating AT&T and Verizon into, porting a number from one carrier to another. So I can go into AT&T store in the US and pretend to be someone else who owns the phone and be very persuasive and insist that this is me, and they'll just give me a SIM card with my number. They can go to the store and say, hey, I lost my phone, I need a SIM card right now. It's important, my wife is pregnant, I don't know. Make all sorts of excuses, and sometimes people will cave because they want to help you. So this is one way that phone numbers can be hijacked, but there are other ways.
Social engineering.
That's social engineering, but there are other technological ways to do that. You had a group of East European hackers that let people, they said, give us $2,000 and we'll give you a copy of every SMS sent to a specific number. And the way they did it, they used the vulnerability in SS7 routing protocol and tricked the carrier to believe that this phone number is roaming to a different country. And whenever they send an SMS, it will be routed to that network in Europe that the hackers had access to. So this kind of thing, it's a problem because it can be patched in theory, but SS7 is a bunch of patches, and you get into a certain point that nothing can help you against it.
It's a design flaw.
Continuously go to both of the.
So I think in this specific case it went both ways,
it goes
because they'll receive it and then they'll reply it to the original network the user is connected to. So there was this kind of complexity to it.
If it was something that was legitimate, they would copy it and resend it. If it was something that they triggered, they
Yeah,
didn't
they'll
bother
drop it.
resending it.
But
if it was a design flaw in the original specification that has been in operation now for 20 plus years.
Yeah, the whole GSM is vulnerable.
Yeah, because it's
They
full,
install
it's
bases
basically
so
full
huge
trust
that they
network.
cannot just fix it.
Yeah, so
they keep on patching.
as I said, you have, you can have a bunch of great methods to do multi-factor, and eventually all of these have some kind of another vulnerability to them. So this is a step in the right direction, but that's not yet the ultimate or the perfect solution. The next option is Authenticator Apps and password managers, push, notification, etc. This is, again, slightly better because usually these apps are installed on your phone and they can't be moved. So if you're using Google Authenticator and you're logging into an account once, the way it works is that you open the Authenticator app, and perhaps I have it to show you. I completely removed it from my phone. So what happens is that you create an account in a service, or you're activating MFA in your account, and then Google will show you a QR code and say, scan this code in your device. And this QR image contains a secret key that is now shared between you and Google, and you use this secret key to generate the changing 6-digit code every 30 seconds. It's there are two methods to do it. There's a counter-based. It's called COTP, counter one-time password, which there's a counter running on, and you use it to generate the code. And you can also do it time-based. It's TOTP, time one-time password, and we're going to talk about this a bit more further.
This is only for Google.
No.
It's a protocol. I think Google were like the main pushers behind it to make it more popular, but it's publicly known algorithm. You just have to have a shared secret between you, and you can derive the code based on the time.
There are many applications that provide this kind of functionality on your phone. For example, I use something called Authy, which looks like this.
They all use the
Then
same.
you just type in and you get the rotating code.
So what happens with this specific solution is Google are not letting you export that secret key. So if you lost your phone, there's nothing you can do. But other password managers, I'm not sure about Authy, but
Yeah, it backs up to
OnePassword
the
lets
cloud.
you sync it to the cloud.
Yeah, it backs up to the cloud using your secure password, and
Yeah.
if you lost your phone, you can use your secure password to retrieve the things that
retrieve
you have.
Yeah, so again, this is having and not really having a different factor, but it's working. One more thing, which is good in this case, is that you have apps like Okta, which is a third-party service that it's a single sign-on provider. You use it to verify your user's identity. So when you log into Okta, you have to type in your password, and then Okta requires you to install a dedicated app on your phone, and they'll send a push notification to that phone. And you can press approve or decline. You're going to see it just in a second. So this is, when you try to log into Okta, they provide you the 6-digit code, which they don't let you export from your phone. And they also, this is my watch app. If you choose the push notification, they'll send you a push notification with approve or deny for each login attempt. So this is a bit better because it can't be moved from your phone, it can't be back to the cloud, etc. It has its other problems, such as, as I said, if someone steals your phone and your phone is not protected by a passcode or something, they can reuse it because they have access to your phone. But again, gaining access to the other factor you own. And by the way, all the way to the right, this is called Google Prompt. This is Google's solution for push notification to the device itself. You have to have the Google app installed, and then it will just show you the prompt whenever you want to sign in.
Yeah, well, the main advantage of using our phone as a second factor is that you can't copy it. Well, maybe you can, but the idea is that you can't copy it. If somebody steals your phone and you know it's been stolen, it's not on you anymore. You know to go and revoke all your authorizations and stuff.
That's correct. Well, one disadvantage is this is also vulnerable to over-the-shoulder attack. So
Yeah.
nothing's perfect.
Everything is vulnerable to rubber hose cryptography.
Yeah. I think this is the least worst option, and that's, I called it protected one-time password, and this is actually having your one-time password inside the password manager, which is protected by another password. Okay, so this is something you have, which you protect with a different thing you know. So I can have my password to access my account, this is something I know, and I can have a password manager, like I'm using OnePassword, and this is the something I have. It's on my phone, it's not synced. Okay.
And what about the old signatures?
The old signatures over
Yeah, when you sign,
credit card note.
it's not just the signature itself, but the way you move.
Yeah, so that's, correct me if I'm wrong, that's, not, how do you say it?
Cryptography.
Graphology?
Cartography, graphology.
Graphology, cartography, it's mapping.
Yeah.
Yeah, I had the same.
Graphology, yes.
So graphology.
There are ways that they're doing it where you can do the motions on a screen or something and it will detect whether the motions match your
We're
number.
gonna talk
pattern.
about this kind
So you
of.
sign like a.
We're going to talk about this kind of fingerprint soon. This is. I'm not sure. I'm not sure it's not broken. I have to say, I'm not sure it's not
It's
broken.
completely fakeable.
Digitally.
It's completely fakeable. You just need somebody practice enough.
Yeah.
But
So
It's easier to break than the voice one.
Easier.
Yeah,
I
you
think-
you just have to practice doing it on a piece of paper a couple of times.
I think the main thing in this part of the presentation, this is actually explaining why MFA is useless. This is the title of the presentation today. And when I'm saying useless, I had the disclaimer right there at the beginning. I had this little asterisk by useless. It's useless for few certain use cases. It's useless to use SMS verification and automated phone call verification in order to, try to limit your website to only serve legitimate users. So, all these sorts of services like Google and Amazon and PayPal has this belief that if you're requiring a user to verify its phone number when signing to a service, then it's gonna save a lot of time and money serving, bots and automated scripts, just creating accounts, etc., because all these scripts has to actually gain access to a phone number and be able to receive a phone call or an SMS and then type it back into the browser. And this is a lot of work. So this is an assumption that services like Amazon has. They believe that asking the user to verify its phone number, it's complicated. And when I'm saying this specific thing is useless, I really mean it, because I'm going to show exactly how it's possible very easily. Now it's available on GitHub thanks to me. So I expect a lot of these from many people. So to people like Eric and Oded that has some expertise in telecom, they know it's not complicated to automate receiving SMS because you have APIs live in the internet for it that lets you do just that, and it's a really simple script. So I actually presented it to a crowd of automation tests engineers. So to them it's like a whole new world of opportunities opening up. Wow, you can receive an SMS into a JSON file automatically? That's crazy. So these are the actual comments, and I can appreciate it, because to us it's simple, but to many other people it's not. So this is my presentation's SMS webhook, and what's going to happen now is I'm going to basically send an SMS to a phone number I've rented from Twilio, and it's going to show up on the screen. Magic. So this is the chat history on my phone. This is a US phone number, and I'll just have someone dictating me a special message I couldn't think about alone. So if you don't mind saying a word in English, I can type in.
Campus Tel Aviv.
Campus Tel Aviv, no problem. Campus Tel Aviv. So I typed it in.
You don't follow instructions very well. It's 3 words.
It's okay, and if you may throw 2 random digits.
17.
17. So Campus Tel Aviv 17. I'm trying to send it. I don't know what's going on. I think I don't have service here. So let's see. Let's see if it worked. Actually. So yeah, Campus Tel Aviv 17, right there on the screen. All I had to do is to refresh that URL. I think it's accessible to you as well. Don't try. So, receiving SMS, it's super simple. This is how you do it. You go to twitter.com, you press on the buy a number over there in the right. This is how it looks, and then you configure a webhook to receive the sender's number and the message content, and that's it. This is exactly what you've seen right now on the screen. It took me 2 minutes, not joking.
Putting in your credit card was most of that.
Yep. Exactly. I actually had an account, so it was 2 minutes. This is another method. We said that using the Authenticator Apps in order to force or keep bots, etc. This is a very common practice to use one-time passwords to keep bots and automated tests and automated software you can buy online that buys tickets in Ticketmaster when there's a new very popular show going live. You have people actually making money from it. There is this Israeli startup called Fiverr. They sell services for $5. You can have someone designing you a business card or recording, IVR voice menus, recordings for you for $5 online. You just type in what you want, and you'll have someone doing it for you for $5. And this is pretty cool. It's a marketplace. It's an Israeli startup. They happen to be our customers, and they had a great problem. Someone would come in with a new service, let's say, and it all starts with "I will do," etc., etc., for $5. So it's "I'll design a business card for you for $5." And they had people, suggesting new services, such as "I'll design a business card for you for $5." And the problem is that they're not the only ones in the marketplace. You had 200 others or 2,000 others. So what they'll do is they wrote a script that just opens 6,000 accounts, all of them with the same description. I'll create for a business card for you for $5, etc., etc. And then they'll just run the script and they'll flood the marketplace. You could browse as much as you want, but every 5 out of 6 listings in the marketplace were the same person, which used the script to do that. And
Wow, it's still happening.
yeah, so it's the same. You have 10 different websites in Israel when you look for a plumber, and then when you go in, it's the same network of plumbers. They just have 10 different websites, and they're all the top for the search in Google for plumbers.
The magnetic.
Yeah, exactly the same thing. So, using Authenticator Apps in order to limit access to the account, it's a great measure, but it's not really helping because this can also be automated really easy, and we're gonna see how that works as well right now. So now I'm gonna move to what's going on. Viewing display. So what we have here it's too much for them. My computer is having a hard time. Okay. What we're going to see now is a Python script that logs into my Facebook account and typing in the random 6 digits I have changing on my phone. This is again a demonstration to show how easy it is to automate this kind of things. This is a Selenium script. As I said at the beginning of the presentation, Selenium is a tool for software developers and automation engineers to basically program your browser into doing certain actions in a certain order. So what happens in the script is that I'm going into, enlarge a bit, I'm going into Facebook, I'm locating the login form, typing in email, password, and hitting login. And then here, with one line of code, totp.now, I'm getting the changing 6-digit code and putting it inside the 6-digit field in the login flow in Facebook. The way it looks is, I'm going to go here to TOTP, Python, Facebook login. It's going to open the browser here. Okay, this is the part I'm going hands-free. So it typed the user and the password, it hit login, and now it typed the 6-digit code. Okay, if you knew my password, these were the 10 seconds to copy it. Just press save and I'm logged into my account. Okay, it was hands-free. I was pointing, this is my computer, it's not a video recording or anything. In fact, we can do it again. I can hit it again, and it's open. Again, the Google settings, it's a new thing. Okay, so once again, 6-digit code, it's a different code from the code before. Once again, pressing continue, hitting save browser because it doesn't know the browser. And again, I'm logged in. So that's it. As you see, it's 87 lines of Python, and that's, you know, with wrapping everything, wrapping the send keys if the element exists, etc. So this is an actual test people can take and run to make sure that the Facebook login flow works. So again, to automation engineers, this is a whole new world. It's rocket science becoming pouring milk into a cup or something. And that's almost the last demonstration we're going to have for today. But there is one more. And this is my cat, by the way. Now, this is the holy grail of automation. This is the part where people went insane in the audience in the automation conference. Automating phone calls using asterisks. So again, for Eric and Oded, this is day-to-day tasks. It's nothing interesting, nothing new. To automation engineers, and I told them, you can actually answer the phone call from a script, receiving an audio, transcribing it, and then using the text to extract the 6-digit code. To give a background, the way it works with Google Register, for example, is that when you create an account, you have two options. You can receive the code via SMS, which is great for mobile numbers, but not every country offers mobile, SMS services for mobile numbers. So if I'm Google and I'm using an API to send SMS, I can't send SMS to every country in the world. There are some countries that have restrictions, some countries that the delivery is not guaranteed, etc., etc.
Or just expensive.
Or just expensive. So Google lets you receive an automated phone call, and then they're saying, "Hi, this is Google. Your code is," and they're just reading you the 6 digits. And that's very nice. This is a background about Asterisk. Basically, it's a software. It's how is it called these days? It's an open source communications engine, real-time communications engine, something like that.
Something to that effect, yeah.
It's a great software written somewhere in 1999 by the guy who invented Pigeon. That's the Linux instant messaging client. There's a guy called Mark Spencer. He's awesome. And he wanted, Mark Spencer, yeah. He wanted to, he had a Linux consulting company, professional services for Linux, and he wanted to buy PBX. PBX is the phone system. You can run at the office, you can connect one line and then have 2 extensions connected to it. And he wanted to buy this kind of PBX back in 1990 something, and it was super expensive. It was like $4,000, I think, or something like that. That's way up. $8,000. $10,000.
You're at least 2 zeros short. Back then, a PBX ran between $50,000 and $500,000.
So that's insane. And the guy was like, "What? I'm gonna do it myself." That's what happened. He did. He created a fully software-based phone system, and then he connected with a guy called, I think it was the dude. Yeah. And they actually created a physical card that let you plug into the phone line in the wall and then have it inside the computer. And that's revolutionary for 1999.
Still revolutionary for today.
Yeah, it's revolutionary for today. This is how Asterisk started. And in Israel, I think it's a 2-digit number of the people who actually use it on a day-to-day basis. Or I'm talking about as professionals, not about as a PBX in your office. As I said, it's annually 1.3 million new installs that adds to the, I don't know how many millions, I think it's hundreds of millions installed worldwide.
I know.
I bet that if you go take a look at the phone system here in the Google campus, it's also asterisk-based, etc. It's everywhere. And today we're going to use it to automate not this kind of flow, which also can be done with asterisk. This is Amazon asking you to receive a phone call and type in your 6-digit that they show you on the screen. This is more simple than what I'm going to show. What I'm going to show is how you receive a phone call, transcribe it, extract 6-digit code from what this phone call read out to you, and then typing it in back into the browser. In order to do that, these are all the prerequisites. You have everything available online in GitHub. This is the link to all the demos you've seen today. It's basically downloading a file, registering into a service like Twilio that lets you receive a virtual phone number and start creating tons of accounts in Google without an effort.
Please don't do anything evil.
Exactly. And you're gonna see it right now in the code that they have like 10 disclaimers of don't try it at home. And oh boy, I hope people listen to me. So we're gonna take a look at a script called Register Google, and this is a demo for educational purposes only. Google, don't sue me, please. It's not intended. Use at your own risk. Everything. This is just in order to show you that it's
Possible.
It's possible, and it's really easy to do that. So once again, this is a Selenium script. All it does, it goes to the Google sign-up page, fills in a bunch of stuff that you have, like personal first name, last name, age, phone number, etc., etc. And then the really interesting part is I'm accepting the terms of service programmatically again, and then I'm moving to a whole different part where I'm waiting to receive a phone call from Google. I'm recording it. I'm sending it for transcription in Google's API. This was the funny part. I had in the previous conference, in the automation conference, I had a guy from Google sitting in the crowd, and the demo there failed so bad, and I was like, "Ooh, it's not working! I'm gonna show you a video recorder." Then I had a video of the demo actually working. It's here on the desktop. And then someone asked me, "Are you seriously using Google's API in order to create accounts in Google and bypassing their security?" And I was like, "Yeah, and it's working." And the guy from Google was like, "What's going on?" So we're gonna see it in action, and then, okay, one more thing before we go and see that. This script is so good, and it can be used right now to allegedly create tons of fake accounts in Google. All you have to do in order to create an account is allocate another phone number here. So let's say I purchased a bulk of 20 phone numbers. I can run from, let's say, 1610 into 1620, and just run this script with a loop 20 times, every time with an incrementing phone number, and I'll create 20 accounts without doing anything else. It's right there, it's working. Don't do this at home. So, what's gonna happen now is I have an asterisk machine. It's running inside Docker. Docker is, any of you don't know Docker as a platform? Awesome. Cool.
None of them know Docker as a platform.
None of them?
No, we don't.
Okay. So, Docker is some kind of a virtual machine service. Basically what you do is you download Docker, you install it on your computer, and then you can find all sorts of operating systems in certain configurations available to really easily be installed. Basically, Docker lets you take a certain system and boil it down into a single file that can then recreate that system with that configuration on different hosts. So in this case, I took an asterisk machine, which is kind of pain in the ass to install manually, and I took an existing Docker file script and I added some stuff to it. So it's just downloading the latest CentOS system from the Docker hub, which is a repository where you have a bunch of operating systems pre-installed. and then it downloads asterisk and configures everything for you. So basically what happens is when you want to run that Docker in your computer, you just have to take these files from GitHub. It's one command, git clone, the repository. Then you have all the files here. And then run this script called build, which will build this single line called Docker build, will create this asterisk machine configured with everything in it, everything you have to do. It will create a copy of it on your machine where you can run it. So, instead of providing you a virtual machine with everything pre-installed, and it will wait, 40 gigabytes, for example. You have few simple files. You can then run them on your computer, and it will compile everything for you on your machine. And after you build it, you just have to run it, which again is a single script. So, it's 3 commands in the terminal, and I'm all good. So, I have an asterisk machine running here, and show registry. This machine is connected to my phone provider. I have the virtual phone number hooked up into that machine. It can be changed very easily in the configuration files. And what I'm going to do next is I'm going to run the script that creates the Google account automatically, hands-free. So this is available in a second. Compose. Okay, now you'll have to excuse me. I'm going to do one thing. Since we've seen that it pops out the annoying settings message, I'm going to put a sleep here. Time, sleep. I'm going to allow myself 5 seconds to close the browser settings window before we continue. So that's it. So, I'm going to run Google Register. Now, of course it's not working. Sorry. Source. That's the Python virtual web. For those of you who are interested, Google Register. Okay, so this is the browser. Okay, we're waiting for 5 seconds. I am enlarging the window a bit. This is the settings. Well, and it's corrupt.
You're still running.
Yeah. We're going to redo that one more time. So, where's the settings? Yes. Cool. Okay, hopefully now it will work. Oh, I think this is Google trying to sabotage my live demo. I'm going to try that one more time. Okay, and I'm going to do something else now, which is I'm going to do this slip and then another slip here. Perhaps it will work. And if not, we're going to resort to the pre-recorded video that saved me less time on stage, which can happen. So, where is this window? Show yourself. It's on purpose. Okay, yeah, I'm using a different Chrome version than I had originally. Yeah. So, this is not going to work live on stage today.
Maybe it's already created.
Yeah.
You need to change the name of the account.
It's okay. No, the account details are changed. What happened is that I'm using Google in incognito mode. Perhaps I can remove the incognito flag and it won't happen. So let's do that as a last resort, and then we'll go to the video. So instead of incognito, I'm running it regular, a la natural.
Continue.
Keep going.
I keep going. So let's see if it worked this time. Almost. Yep. Let's hope it stays that way. Yeah. Okay. Something has changed with the Google Chrome version I used in the previous presentation to this one, so I'm going to fix the script and I'm going to show it to you. I'm going to publish it, the updated version. Yeah. Until then, we're going to go to the video that saved me previously, which is called Kittens, and this is an actual demo of everything working. Okay, so this is working, it just needs a bit more manual tweaking. I'm going to the Google page. This is the Selenium Script advancing. This is the voice machine, the Asterisk machine. As you can see, I'm accepting the terms of service. And then I'm choosing voice call. This is the part I'm waiting for an updated call recording. Okay. This is my script observing for file system changes, looking for a new recorded file. This is the actual recorded message from Google. Hey, your phone is blah blah blah. Your code is blah blah blah. And this is obviously taking time because it takes time to read out your 6-digit code. And whenever that is going to be ready, I'm going to send this is the Asterisk machine answering. As you can see, it's writing it into current record. When this is going to be hanged up, it's hung up. Sending file for transcription. This is the part of the script sending to Google to receive the actual code. And then what's coming back is your code is 43 da da da. It's typed into. Now I'm waiting. This is fine. You can see everything working. This is the code. Code is right there. I hit continue, and I got an actual account working in Google. So everything happened hands-free.
The call is to your mobile, yes?
No, the call is to a virtual phone number.
To virtual, okay.
Okay. So I received the call into a virtual phone number, and it was a landline as well, as you've seen. It's 072. You can see it here. Sorry, you can see it here. Oh,
Yeah, there's a,
so it's a landline in Israel. So you're receiving a phone call to a landline. It's all transcribed. Actually, I can play you the recording.
No, it's okay.
Yeah, no. The previous recordings, they're on the machine. So, second demo, phone calls, one back, recordings. This is the last recording I had on the computer. I hope it's not me blabbering. That's actually Google. So that's not working. Never mind. You've seen the purpose. You've seen it's creating the account, etc.
It's a virtual
Virtual phone number. I received the call into the Docker machine you've seen, recorded it, sent it for transcription on Google, got it back. All the code is available online. You can take a look at it. See, it's really simple. It's readable. You can see the whole process boiled into the code. I know it's gonna crash back there, because this is like, it's very fragile. The whole process of receiving a phone call, transcribing it, typing everything back. So these are the, oh crap, everything burned live on stage. Don't kill me. You've seen the video. It's working. I can explain to you why it's working. And this is the last slide. Don't worry, we're done. So as you've seen, everything can be automated pretty much. Even we talked about voice biometrics. Nowadays, that your voice can be synthesized. Obviously, you can have a recording played into a phone system, etc., using all these kind of automation tools. So nothing is safe. Okay. My personal belief is that we're going to see more and more companies like Google, like Amazon, advance the same way they did with payments. You have Google Payments, Amazon Payments, etc. They're going to do the same to authenticate you. This is called single sign-on provider. Google are already doing it. You can sign into websites with your Google account. This is single sign-on provider. I think the security, the authentication of the user is going to be done more on their side. Google already launched enterprise authentication service, which basically lets you, as a company that uses the G Suite, the all set of products by Google, define from what devices your users are allowed to log into the company resources. So let's say you have sensitive stuff in the Google Drive, you can configure a certain sensitivity or risk level of devices, which above those you're not allowing access. So let's say I have a Google account, I've got a new phone, I've installed it on the phone, and Google knows nothing about this new device. It probably won't let me access really important company resources.
This is, by the way, classic MDM. Google offers MDM as one as part of the G Suite suite of application. what other providers have been doing for a while. Microsoft is a good example, McAfee or Intel, the way how you want to call it, Norton.
Yeah, so
they all provide MDM.
This is not pure MDM. They also let you do that on devices which the MDM is not installed. They let you assess the risk of accessing from that device. So let's say if you're logging in from a public internet cafe, they won't let you access anything.
Yeah,
important.
because you're MDM-less. But the minute you have an Android device, the Android device is MDM
Yeah,
managed.
but let's say that a really sophisticated attacker just bought a new device,
Yeah.
and he's logging into that Google account on the device itself, not just on the browser, and having putting it for a few days in order to gain credibility. They claim that they still know how to separate the actual user from someone
Yeah.
who is impersonating. One cool thing, as I said, that we're going that direction. We're going to the area where companies are gonna, they know you really good. Amazon knows you really good if you buy stuff at the website. Google knows you if you're using an Android. Apparently, according to a week from last report, they're tracking your location even when the location services are turned off.
Yeah.
That's
They
fantastic.
admitted. They admitted.
Yeah, they admitted starting from this January. So everyone who has Android from this January, congrats, Google knows where you've been for the past 11 months. So companies like Google obviously are going to offer this kind of thing. I don't know if it's going to be in the form of insurance to service providers. So say, listen, let users log into your service with Google account, and we'll guarantee that these are the actual users. It's going to go that direction. You have companies in Israel. There's a company, I wrote the name, BioCatch. BioCatch are basically claiming that from the way you're holding your phone in your hand, this movement, this is a unique fingerprint for a user. They say they can identify the user by the way he's holding or she's holding their phone. So they provide an SDK or something that basically says, listen, you can have, just by the way the user picks up the phone from the desk, you can know this is the user and unlock the device. Sounds cool. I don't know if it's working. I guess there is a possibility that it's actually working, and it's
Well,
The advantage-
they raised a lot of money on it.
there's a
That's
great
the first
difference
step.
from raising money into actually,
No, but that's what they got a lot of money now. They can celebrate, but then they have to move further.
It's
Okta, by the way, already became public. I don't follow the valuation, but it was something, I don't know.
but Okta, we have Okta in our company.
Yeah, but they became public, I think, last year for an enormous amount.
But they're nothing but a single sign-on provider.
Yeah.
Nothing special in their product.
Right.
That's my opinion.
But they sold a good story and they got a valuation of
Exactly.
The advantage of machine learning is you can pipe in any kind of data input and get any kind of decision you want, whatever meaning it means. It's between the marketeer and the customer.
Exactly. So, this is. I think it's eventually going to be possible doing all these kind of things, but we're not there yet. We're going to get there.
We should compare to storytelling.
Yeah.
How to market our technology.
Exactly.
So let me go back to the first slide,
Yeah.
if you may. Can you go back to the first slide?
Although,
So, when they say MFA is useless, you don't mean useless as a general concept, but
I mean,
relying on multi-factor authentication to verify that the person that the thing you're talking to is a human and not a bot, for that it's useless.
100% useless. Yes.
But using it for making sure that the person you already know is a human is still a human.
Yeah. That's
That-
also. That's
But
also.
that's still sometimes useless because, like, the SS7 problems with SMS and things like that. Yes, you know it's a person, but so what? Somebody else can be imitating the person you have in mind.
You have to carefully choose your second or third factor.
That's correct, and I'll give you more to that. It's
There was also another startup by a PhD student, a graduate of photography, and I think LEBM from the Technion department. It's called Verify You. It also needs some sort of,
there's been a startup who used what sound frequencies you can't hear in order to perform two-factor authentication on your computer. They come and go. When I'm saying useless, I mean, you know, we talked about the way to separate humans from non-humans, but we also talked about the vulnerabilities in SS7, which kind of breaks the purpose, and also the way that you can mirror all the SMS you receive from your phone into your computer, and you know, having your tokens hosted in the cloud-based password manager. So when you're using it in all these ways and for all these purposes, it's either useless or losing from the, you know, from the idea, which is pretty good, but it depends on the execution.
There is also a simple thing that computer cannot read. Captcha.
Yeah, so CAPTCHA, by the way, CAPTCHA and reCAPTCHA by Google were broken officially. There's a repository available online. I can also share it in Peerlyst or something later. That actually took the CAPTCHA's read me the notes option, you know, for people.
Play the recording.
The accessibility option, where it plays a recording of, you know, saying, let's say the code is ABC, so it's saying A, B, C, and you have a bunch of background noise. And they were able, using built-in utilities in Linux such as socks, reduce the background noise and extract all the right notes and type it in automatically.
Another, when you say where is the car in this picture?
Yeah, so this is the new CAPTCHA by Google. They're gonna eventually break this one too. So, but this is also not accessible for people with you know, visual issues, etc. So thank you. I hope it wasn't too.
The thing with the voice detection, it's a problem because it's again it's an arms race, because the people who produce these obfuscation methods for voice are also the same people who try to understand human voice to be able to provide things like virtual assistant and stuff like that. So basically, they're both fighting against themselves.
Yes.
Yeah. So
this is very much an arms race category thing. Every time we find a better way to secure it,
we'll find a
6
way to
months later
bypass it.
somebody will find a better way to break
The
it.
thing is, they don't break it to break it. They break it because they want to make better products for people to, for example, to be understood by computers.
Yes, Adobe did not go out and design a system specifically to break voice security. It just happens to be a side effect.
So I hope, you know, we've got some new terms familiar to you by now, and you know, automation can be cool. By the way, this is also a message from this presentation. And if you have any questions, I'm available here right now, LinkedIn, Peerlyst, etc., etc.
The Meetup group, you can put questions at the comments on that.
And thank you for your time.
Thank you very much.
The official